Good morning. Myself Dr. C. Vijay Kumar, Associate Professor, Department of Mechatronics Engineering, K.S.Rangasamy College of Technology, Tirchangood. Today we discuss about the chapter of thermal energy based non-conventional machining process. Under this chapter we are having different types of topics. So first topic we discuss about classification of thermal energy based process. Under the classification of thermal energy based process, first one is the laser beam machining process. So the principle of laser beam machining process, it is one of the non-conventional subtractive machining process using the thermal energy of the laser beam. The thermal energy is converted into mechanical energy to remove the material from the workpiece. That is called as a laser beam machining process. During the machining process, a high energy laser beam falls on the workpiece surface and remove the workpiece material by heating, melting and vaporizing. You see, this is the entire laser beam machining setup. The outer, the green color is a coolant jacket under the one structure. After the coolant jacket, we are having a ruby laser bulb. The ruby laser bulb. This is a xenon tube, and the xenon tube is wound with the ruby laser bulb. The electric supply is connected with the xenon tube. Then this is the lens. The bottom one is the workpiece. Workpiece is fitted at the workpiece holder. Okay. Once if we energize the electric supply, the xenon tube is closed. Once the xenon tube is closed, the ruby rod emits the laser rays. The laser rays is scattered. We are using lens. The scattered laser rays is converted into one particular focal point. The focal point is narrowed on the workpiece. Where the focal point of laser is hit on the workpiece, at the place the metal will be removed. It is called as the laser beam machining process. The different types of laser used in this laser beam machining process. First one is a gas laser, another one is a solid laser. The gas laser, in this type of laser, gases are used as the medium to produce the lasers. The commonly used gases are helium, neon, argon, CO2. These are the compounds used to create a gas laser. Suppose if you are using the solid state laser, the media of the solid state lasers produced by doping rare element into host material. That is called as a ruby laser. The ruby laser is one of the example of solid state laser in which ruby crystals. We are using in laser beam machining ruby laser, ruby crystal is used. The laser beam machining, the advantages of laser beam machining, it can be focused to a very small diameter. It produces very high amount of energy, about 1000 megawatt per square meter of area. It is capable of producing very accurately placed holes. Laser beam machining has the ability to cut or engrave almost all types of materials. Since there is no physical contact between the tool and workpiece, the wear and tear in this machining process is very low, hence it requires low maintenance cost. So disadvantages of laser beam machining process: high initial cost, highly trained workers required to operate the laser, because this laser is involved in this process, so we need high skilled laborers are required. So low production rate, since it is not designed for the mass production. It requires a lot of energy for machining process. It's a high maintenance cost. The next process is plasma arc machining process. The plasma arc machining process is a method of cutting metal with a plasma arc or tungsten inert gas or torch. The torch produces high velocity jet of high temperature ionized gas, that is called as the plasma, that cuts by melting and displacing material from the workpiece. Plasma arc machining process used ionized plasma to transfer the heat. The plasma is obtained by forcing gas through an electric arc generated between the cathode and the anode. The high temperature plasma jet melts the metal and removes the workpiece. You see, this is the entire structure of plasma arc machining process. The outside the black line is called as a anode. The black line acts as an anode. Then red color is water cooled nozzle. It's a water cooled jacket. That black color is a electrode. It's act as a cathode. The outside shield is act as a anode. The in between the black color is act as a cathode. That is a tungsten electrode. The electric supply is connected to negative terminal is connected to the electrode, positive terminal is connected to the workpiece and that outer shield. Both the things are connected to positive. The electrode is connected to the negative. Then in between we are supplying the gas. Ionized gas is supplied. Gas is supplied in between of water cooler jacket and outer shield. Once if we energize the electric supply, then automatically in between of the gap, that's a 2 mm or 3 mm maintained in between of tool and workpiece, then automatically arc produced. At the time we are supplying the gas is combined with the arc. At the time we are getting a ionized gas. That ionized gas is called as a plasma. It's at a high temperature. The high temperature melting the workpiece automatically remove the unwanted material from the workpiece. We are getting a machined surface. That is called as a plasma arc machining. So advantages of plasma arc machining: hard as well as brittle metals can be easily machined. The plasma arc machine gives a faster production rate. It can be used for rough turning of very hard materials. It is also used in machines that are used to repair the jet engine blades. So some disadvantages of plasma arc machining is that the equipment used in plasma arc machining is very costly. The consumption of inert gas is high. That inert gas is used to get the ionized gas. That's the plasma. There's oxidation and scale formation takes place, shielding is required. Then application, it's used in mill applications. It is also used in nuclear submarine pipe systems, used in welding stainless tubes. It's used for profile cutting. The next process is electron beam machining process. Electron beam machining process same as plasma arc machining, but instead of plasma we are developing the electron beam using of cathode and electrode. That is called as electron beam machining process. We see electron beam machining is a process where high velocity electrons concentrated into a narrow beam that are directed towards the workpiece, creating heat and vaporizing the material. Electron beam machining can be used for very precise cutting or boring a wide variety of metals. You see, this is the entire setup of electron beam machining. The first one is a high voltage supply. This is the cathode. This is cathode. We are supplying the voltage. Following the cathode, we are having a cathode cartridge, then bias grid, then anode. Then vacuum throttle valve, then port diffusion purifier, then magnetic lens, then lighting system for alignment, aperture, electromagnetic coils, deflector coils. Under them the workpiece. Last one is workpiece. Once if we energize the supply to the cathode, automatically the cathode will emit the electrons to the anode. Then electron beam will develop through this magnetic lens. Then lighting system for alignment. The scatter electron beam is developed. We are using lens and lighting alignment. We are focusing in one particular point using electromagnetic coils, then deflector coils through the workpiece. Once the electron beam is hit in particular place of workpiece, the metal will be removed automatically. Then we change the place of focusing the lens, focusing the rays, electron beam by using deflector coils. We move the deflector coils, then the position is changed automatically. The metal will be removed in a different places with the using of our requirement. This is called as electron beam machining process. Then the electron beam machining works when the electron guns generated the electrons with high velocity output and reaches to the anode, which are arranged in the below cathode. After passing it enters the magnetic lens. We discussed about the same thing. We passes the electromagnetic rays to the lens and adjusting mirrors. We focus on particular point. That particular point metal will be automatically removed. Then advantages of electron beam machining: it can produce high surface finish. It can machine small diameter holes. High drilling rates are available. The disadvantages, this can only remove less amount of material from the workpiece. Then skilled operator member can only operate, because we are enabling the cathode, anode, then electron beam also producing, so we need a skilled operators. Then equipment of electron beam machining is very high compared than other process. These are the some advantages, disadvantages of electron beam machining process. So thank you for watching. Keep learning and growing. Thank you once again.